All right. Well, first of all, speaking for me, and I don't want to speak for Aaron, but I'm glad to be here. I'm sure he is, though. It'd be really awkward if you said I'm not. So I'm sure he is. So yeah. The topic we're talking about today is OAuth 2. OAuth 2 plus. O and 1 a little bit, right? Or 0 and 1, not and 1, depending on where you're at, Z, whatever. And when we did meet a while back, we got this, I'll be real honest, I'm not an OAuth expert. Aaron is the OAuth expert, but I read his book, and it helped me a ton. And so, Aaron, I want to start out. You like to make an assumption. Everybody knows what OAuth is, but that's probably not the case. So, would you first of all, you probably want to introduce yourself, but would you give an overview in an elevator pitch? What is OAuth and what is OAuth 2.0?
Yeah, thanks. Thanks for the introduction. I'm Aaron. Everybody, nice to meet you, and nice to be here. So quick summary of what OAuth is, I guess. It started out as a way to log into third-party apps so that they could access data in an account. So think early Twitter days when there were a lot of third-party Twitter clients. It was a way to let those third-party Twitter clients post into your account, view your timeline and all that without sharing your password with those apps. And it's really grown from that point, and it covers a lot more ground now, and it's used as the sort of foundation for just generally signing on to things on the web. So it's used for first-party apps as well, and it's extended into new use cases that weren't necessarily part of the original sort of scope of what OAuth was created. So it's really the foundation of, if you're logging into a website somewhere that without just a simple password, it's probably using OAuth.
Okay. All righty. So to clarify, because this is one of the things I really hung up on a lot. We have this thing, and you hear terms thrown around. We have AuthZ and we have AuthN, right? So what is the difference? So those are obviously authentication and authorization. Talk us through the difference a little bit on that.
Yeah. First of all, I'm not really a big fan of those terms because they sound almost the same, and I feel like they get thrown around just to confuse people. And, so yes, there's a difference. However, I like to think of it more in terms of the what's the end goal. So the end goal of AuthZ authorization, it's always about accessing data somewhere, right? Like, is this person authorized to access data? So the goal of that is that an application is trying to get access to something, and right, in order to do that, it needs to get in the OAuth world what's called an access token. Now, that actually is a very different problem from figuring out who is the user sitting behind the keyboard, like who just logged in. And that's the other side of it. That's the authentication side. And I like to think of that as just like identifying the user. So it's either accessing data or identifying the user. And those are really the two different sides of that coin. And there, of course, are a lot of similarities, but there's also a lot of differences. And plain OAuth by itself is only the accessing data part. That's all it does. It's about getting access to some API somewhere. If applications do need to know about who the user is and add in the identity information, you actually have to start adding things into OAuth because OAuth doesn't give it to you. OAuth doesn't include anything about user identifiers. So you'll see OpenID Connect being talked about as the sort of identity layer on top of OAuth, and that's because it is built on OAuth. It is using the same foundation and all the same patterns, but that's where the identity aspect is added into the flow.
So that's an interesting distinction, and I think a lot of folks, including yours truly, would be confused. OpenID, OAuth, same thing, right? They're not. So if I understood you right, OAuth, it can be a transport kind of for OpenID. Would you say that?
Yeah, okay. More or less. So OpenID Connect is adding in this idea of user identity, and the sort of the form that takes is in this ID token. And that's basically just a way for the server to say, here's who logged in. Like, it's communicated in this blob of text. And the way that is sent to the application is through an OAuth flow. So it'll do the same flow as any OAuth flow where the application would get an access token to be able to go access data somewhere. However, instead of an access token being transported, it is now also an ID token.
All right, so let me ask you this: we're throwing token around here. Yeah. So so I'm just gonna JWT token. Is that OAuth?
No. So JWT is a type of encoding of data and signing it and turning some sort of structured JSON data into a signed thing, or encrypted, or both, where it can be moved around and then validated later. And that has nothing to do with OAuth. It has a little bit to do, it can be used along with OAuth or in OpenID Connect. By itself, it's actually useful in a lot of different contexts that have nothing to do with even the web. It can be used in a lot of different things because it's a convenient format for packaging up data and signing it. In the OAuth world, you will see it be used quite a bit. And it can be used as a format for access tokens. It is the format defined for ID tokens, but it isn't, but it has a lot of uses outside of that as well.
Okay, all righty. So
and the opposite is true, where you can do OAuth without JWT.
Right, okay, that makes sense. And JWT without OAuth. So passing, okay. So again, a transport. So or a type of. So okay, that makes sense. So you did when we were talking about the book and we were talking about OAuth. It was really interesting, and I know you kind of already introduced what is OAuth, but there's a history here on why OAuth and we're now there was why. Well, let me just ask a question. Why was OAuth created? Just get that. I thought it was really interesting. Did a little history about that, and then there's an OAuth 1 and there's an OAuth 2, and then we'll move on to the next one again. But why and then why what's the difference between them?
Yeah. So the original goal with OAuth, the reason it was created was because there was this very prevalent problem of specifically third-party applications asking the user to enter their password to go access an API. So if you downloaded a random Twitter app off of the iPhone, I don't know if the App Store was even around when that first started.
Yeah, exactly.
But off of, you download a Windows app, you download a .exe, right, from some website, and it's a Twitter client, and then it says, we need to get access to your Twitter account. Please enter your password. Well, by typing your password into this application, you have no idea what it's going to do with your password. You are crossing your fingers that it is doing only legitimate good things. And just cross your fingers, hope it works. And you don't really get any assurance at all. So it could be logging your password, sending it off somewhere else to be used. It could be trying it at other services in case you've reused your password. There's no guarantee, right? So that was clearly a problem. And sure, Twitter is maybe not the most valuable thing to attack with that pattern, but that pattern happens, it's the same problem no matter what the service is. So there was a clear need for a way to let third-party apps access these APIs without sharing passwords with them. So that's where OAuth was originally created to solve, and that was OAuth 1. And Twitter actually implemented OAuth 1, and that's why we were able to have a lot of third-party apps, third-party Twitter clients using the Twitter API without having to worry about passwords being shared around. So OAuth 1, it was, I would say, reasonably successful in that it was implemented by many major providers to solve this very real problem. The problem with OAuth 1 was that developers hated it. So it was...
that'll end your day right there.
Yeah. So... First of all, it's a lot of new terminology to learn. Like there's just a lot of new terms being thrown around because of this new pattern of accessing APIs instead of just throwing an API key or whatever. Right. But it relied on a signing mechanism that was, I would say, not good, just awkward. Like in order to sign a request, you had to sort your form post parameters in alphabetical order, and then turn that into a string that you would then sign with the signature and attach that signature somewhere in the payload as well. Which meant also verifying that on the other end is you have to canonicalize the request you're getting in order to do the same signature. Signing stuff and actually not the signing is easy. Signing is you throw it at a crypto library and it'll do it. Right. Canonicalizing the thing that you're signing is the hard part. So if you
hang on a second. What does canonicalizing mean? All right. I'm sure I know, but maybe somebody else doesn't. So
if I'm going to send you a message that I'm going to sign, and the message is going to contain two parts. Let's say it contains the text of my tweet and a location, right? So like a location ID of here's the location I'm at where I'm tweeting, and yeah, puts the little marker on the map on the Twitter.
Right.
So if I'm going to send you those two parameters, I need to then sign my request. So I need to turn those parameters into a string of some sort in order to throw that at a library to create the signature. So how I create that string is the canonicalization step. So if I create that string by saying first parameter is going to be content, and then the text of that, and then a new line, and then the location, the word location, and then the location ID. The canonicalization algorithm in that case is the content first, a new line separator, the location next. Now, if you get that request and you want to verify the signature, you have to be able to also make sure that you're checking it against the same serialization that I chose. And with form post parameters, the HTTP form post spec does not require that you send parameters in any particular order. It means the same thing. So if I sent you the content first and location second, it means the same thing at the other end as location first, content second.
Right.
And more importantly, a lot of HTTP libraries might do different things with the thing they get by the time they expose it to the application.
Okay.
So you need to know, like, you can't guarantee that your HTTP server has exposed the data in the exact same serialization that I sent, because in HTTP, it doesn't matter. So because we've lost the canonical form of the request, we need to be able to recreate a canonical form, which is the canonicalization. Right. And that's where you get into, well, we have to just choose something. So OAuth 1 chose put the parameters in alphabetical order. Seems logical. But now you got to write that code. And then if you get one little thing wrong, the signature is going to fail. Yeah. And then you're just like, it's not working. What's going on? And it's hard to sort of, it's hard to do that. It's not fun. It's not, there's very little feedback given. It's not fun code to write. So it was just very frustrating. And that was, I think, one of the big failures of OAuth 1 was baking in that signing at that level. It meant that every app developer had to worry about it. And I mean, I guess realistically, it's every OAuth client developer where, now you don't go write that code from scratch. You go grab a Twitter client in your language, but somebody wrote that client. And there probably aren't that many of them in your language because it's so not fun to write that once one person does it, no one wants to do it again. So it's not very good spec design when like it sort of forces there to be very few implementations because it's so hard to write. So in OAuth 2, the big shift, which was actually a pretty big argument, which is still kind of an argument today, was dropping the need for that signing step entirely. And you have to remember, go ahead.
I was just and I don't want to break your train of thought, which I've already done, but it's interesting in your book, you kind of walk through some of the dynamics and drama that went into this in some of the and if you get a chance, it was really interesting to me because I was expecting when I read the book, do this, very kind of clinical and whatever. But it was really interesting. You should read this OAuth book. It's got a great antagonist, protagonist. Yeah, I mean it was interesting to hear kind of all the stuff going on behind it. So that had no point, but I just wanted to call that out if you haven't read it and break your train of thought. So now back to you. Sorry about that.
Okay, so no problem. So that was one of the big challenges that a lot of people were seeing in leading to less adoption than maybe necessary for this to actually take off. So once it got brought into the IETF standards group for working on the sort of next version of it, there was this decision to take out the need for that signing step. So back when OAuth 1 was created, this was 2000, I want to say like 6, 7 to 2010. Okay. Deploying a SSL cert on a web server was a challenge and also expensive. This was back when companies were charging a lot of money for certificates. Wildcard certificates especially were very expensive, and it just was a lot of work. And because of that, you had to do signing. You had to be able to not require HTTPS and still be secure. which
Right.
sounds challenging, and it is because HTTPS is so useful. But one way you can do that is by doing your own signing. You do your own signature method in the HTTP transport. And so it's not encrypted, but it is signed so you can verify at the other end.
Sure.
And that works as long as you're not sending the key, right? You have to be using a private key to calculate the signature. Once you can assume HTTPS, most of those problems go away. And now you're facing a different set of problems. So thankfully, actually, realistically, it may actually be partly because of OAuth 2's decision to drop the signing from the transport. It basically required that the only way this is secure at all is over HTTPS. Because what OAuth did with the access tokens was said that it's a bearer token, which means it's just a fancy word for if you have the token, that means you can use it. And that's all you need in order to use it. So it's like a house key, right? If you have a house key, you can open the door. You don't need anything else. Or like a hotel key. If you have the key, it works. You don't need to also prove something else. Whereas in OAuth 1, that access token wasn't useful by itself. You had to also have your secret key that was issued to that application ahead of time.
Okay.
So
go ahead. There's something percolating, but go ahead.
Okay. Yeah. So by OAuth 2 saying we're just going to use bearer tokens, and we're going to that forces HTTPS to be required, because without HTTPS, anybody on the Wi-Fi, on the coffee shop Wi-Fi, can steal the bearer token, right? So forces HTTPS everywhere, which is good. And I think that actually was a big reason why HTTPS was then sort of accelerated, and now it's something we don't even really worry about anymore. It's just a default that of course you're going to deploy HTTPS on your server.
Right.
So yeah, OAuth 2, that bearer token idea, it was actually taken out of the core spec because of the disagreements around whether this was a good idea. And there was a pretty big split in the community around, is this a good idea, or should we still require some sort of signing mechanism in the spec in order to use tokens? Okay,
so going back to the SSL as well, you know, back then there was so much overhead as well, not just in encryption, but just, you know, the server overhead to do the encryption, things like that. So that obviously has changed a lot. But okay, so we come to this idea and of now we got this bearer token. It has to be HTTPS. If you have the token, you are in. That's that way. And you know, the server may look at the token, look at the credentials, but if you have it, you're in because you're authorized to do that. It's assuming you've already authenticated, proved who you are to get this. That's generally the assumption now. That's probably not as secure as it could be, though, is it?
Yeah. So I mentioned that it's the reason that it was controversial was because there are still some cases where this level of assurance isn't good enough. And it definitely is dependent on your scenario as to whether you care about the particular attack, because there's no such thing as perfectly secure. In any system, there's only security against certain attacks and levels of assurance of how certain you are that you are secure against a certain attack. So what HTTPS does is it encrypts the transport, and we generally rely on that being uncrackable. And for the most part, the entire world relies on that right now, and it generally is. However, so that encrypts the transport, which is fine, right? So like if I have a token and I make an HTTPS connection to a server, I know that no one's going to get it along the way. Fine, great. There are other ways tokens can be stolen. And that's what this HTTPS does not protect against at all. So if I'm holding on to a token and then someone can steal it from me, then they can use it and they look like me when they use it, because all you need is a token. So if you are if you're writing a server-side app that's running in some sort of, you know, .NET, Java, backend language, whatever it is, generally you don't really have this concern. Like it's almost impossible for someone to steal a bearer token out of that server because it's stored on the server. It would be a pretty big deal if that was stolen, because it meant that they like hacked into your servers.
You got a problem.
You have a lot more problems than just the bearer token being stolen. But in the case of like a JavaScript app, that's a totally different story. So in a JavaScript app, the token ends up being stored somewhere available to the JavaScript code to use. And if your JavaScript can read the token, then any other JavaScript that ends up running on the page can also read the token. So think about how many third-party JavaScript libraries you're using. You might have hot linked ones from your analytics, your ad network, whatever sort of crash reporting system you're using. And then you might have bundled in libraries that you're using from NPM or whatever, where you're bringing in third-party code that you didn't write, but then it's included in your application. All of that code has access to the access token. And that means that any of those, like, you don't really know if any of those are stealing it and then siphoning it off somewhere. So
yeah,
that's generally, again, it's usually fine because you are reasonably sure about like only using trusted libraries and you generally trust your ad network and all that stuff. But you're never really sure. And one of the biggest problems here is this, cross-site scripting attack, where if there's a bug somewhere and someone can drop in malicious JavaScript, then they can start doing bad things, including stealing these tokens. So that's the real issue with bearer tokens is if you can manage to steal it somehow, not while it's in transit, but while it's at rest, then it's game over. It's you got the token.
So in your book, you talk about a couple of ways of fighting that. One is client side, one is server side. If I'm not mistaken, if I've understood. Well, let me throw it this way. One is timeouts and verification of use. I think you suggest, and I'll let you expand on this a little bit, but one of the things you suggest is when a token comes into the server, is that already being used somewhere, maybe another IP or something like that. So that's one way. And then you also talk, they should time out short timeouts. I think refresh tokens tend to be longer. Actual access tokens need to be shorter. How does that help?
Yeah, there's no good solution. It's just levels of assurance again. Like what are you trying to protect against? How willing are you to take a risk? And there are a lot of tools you can get, a lot of knobs you can turn. So that token lifetime is one of them. Like if you give a JavaScript app an access token to last forever, that's the highest risk, because if it's ever stolen at any point, it can be used by the attacker and it will look the same as the regular app using it. And if it never expires, then it's just going to be used forever. A lot of times you'll see with JavaScript apps, people will issue shorter access tokens. That way, if one is stolen, it's only good for a short amount of time. And then you have to steal it again, which, depending on how it's stolen, again, may be easy or not.
Right.
And then, the other one is if you start doing heuristics around like, okay, well, I see that this access token is being used from a completely different IP address. It's still possible. It's legitimate. Like, sure. I got on an airplane and I fly to another country and I open my phone, same browser, same access token, new IP address. It's possible, but it's a signal that you can decide whether or not you think it's suspicious based on other factors or what action is being done. So, but none of those are like super certain, right? The only super secure thing you can do is not using bearer tokens. And we are seeing a lot of that attempted to be solved now in the OAuth world with varying levels of success.
Okay, so, and I know we're running out of time here. So I want to go to, so we talked about OAuth 1, we talked about OAuth 2. So 2.1's out, right? And that addresses...
on its way.
On its way, sorry. 2.1's out on its way. That's what I meant. And so what specific things... now, and I think you had said earlier, I saw a presentation where you had said they're not looking to change the spec, but to solidify it, clean it up, and things like that. So talk to me about, I want to kind of incorporate this. So PKCE is one of them, right? And that's what I was talking about, kind of the client side, server side. So talk to me about PKCE and the changes with that. Maybe what is PKCE and what are the changes with 2.1 and some others?
Yeah. So 2.1, the reason it's not called OAuth 3 is because the idea is that it is still based on OAuth 2. It's not a breaking change like from 1 to 2. And the whole idea is that OAuth 2, originally the core document was published in like 2012, started in 2010. It's gotten a bit messy over the last 10 years. There's a lot of parts to the picture. I mentioned the bearer tokens are not included in the core spec because of that disagreement. Instead, there's a separate document published about bearer tokens. And that's kind of how the work is continued, where there'll be a new document published to fill in a gap or explore a new idea. You mentioned PKCE, which is a very good idea for protecting the actual OAuth flow itself. It doesn't protect things. It doesn't protect tokens at rest, but it protects the issuing tokens and the actual OAuth flow. And as we've learned through several years of experience, it actually protects. It's actually useful in all the different situations OAuth is used for the web server apps, single page apps, mobile apps, and it should just become a part of the core OAuth spec. And there's a handful of other things as well. Same idea, where it's like generally when people talk about OAuth 2, they actually are talking about a specific set of technologies that happen to be currently documented in 5 or 6 RFCs. So the idea with 2.1 is to roll them all up. Let's collapse them all together. Let's publish a new document that's kind of like a new starting point. That way you don't have to go read 6 RFCs in order to catch up to where the industry is. There's a new starting point, which we're going to build off of then from there.
Okay. All right. So what I wanted to do here real quick, I have a couple more questions, but we got about three minutes. I wanted to see if anybody else has any questions they wanted to ask. Aaron is the expert. I'm just the pretty face here. Aaron is the expert. So if you have an OAuth question, I would jump in now. I'm a serverless guy. If you have a serverless question, we use OAuth and serverless quite a bit with Amazon HTTP or API Gateway HTTP APIs and JWT and all that kind of stuff. So I have some familiarity, but I've cleaned up my implementation based on a lot of stuff that Aaron has taught me. So feel free to type it in the chat or just come online and ask. I'm glad to pose the question if we have just a few minutes. If not, then I got another question. Look real quick here. Not seeing any questions coming in at the moment. All right, so I'm going to ask you a question. Actually, if you can, again, that elevator pitch, explain PKCE. And that's PKCE, right? PKCE? Yeah.
PKCE. Let's see if I can do this in 1 minute. So okay. The problem with an OAuth flow and OAuth exchange is that we're doing this entire thing with redirects. We're redirecting the user out to the OAuth server and then redirecting back to the application. That redirect step is happening through the user's browser, where rather than a direct connection between the two parties. So we don't have the client talking directly to the server. We have them redirecting the user, sending data through the redirect. Anytime you're doing that, it's kind of like putting something in the mail and then hoping it gets there. And you're generally reasonably sure it's going to make it, but you can't actually be sure. And when you get something in the mail, you don't actually know who it's from. So we need to add some sort of verification of, yes, this message actually did make it, and I know it made it to the right person. And that's what PKCE is doing. It's basically a way for when you are about to somebody, you're going to send a message, you make up a secret and hold it, keep it secret, sending only a hash of that out in the request. That way, when you go to use the thing you got from in the mail, you can then make a direct connection, providing that secret, which can then be verified by the server doing the same hash. And now you've kind of closed that loop of, you do now know that thing being delivered is being delivered to the right party that requested it, and it wasn't stolen in the middle. How did I do?
Okay. That's pretty good. Seconds. Yeah. Good. You hit it. 1040 right there. With that, we are at time. Aaron, it's always fascinating, and I could sit here for hours and ask you questions. Really,
I enjoy talking about this stuff.